I just rewrite it by bringing the 4 out and bringing that dt up top. And instead of 9, just make that 3 squared. Instead of 81t squared, make that 9t squared. Okay, so we know our a is equal to 3. And our u is equal to 9t. Okay, so that means our du is equal to 9 dt, which means our dt is equal to du over 9. Okay, so now all you have to do is just plug it in. Okay, so our dt, you know that's du over 9, so I just made that 1/9 times du. Over your square root, your a is equal to 3, so you have your a squared minus u squared. Just bring that 1/9 right out to the front. You have 4 over 9 times the integral of du over the square root of a squared minus u squared. Okay, so that's 4 over 9 times the sine inverse of u over a plus c. So that's 4 over 9 sine inverse. Our u is 9t. Our a is equal to 3 plus c, which is just, let me bring that up some, 4 over 9 sine inverse of 3t plus c. All right. Any questions on that one? All right. For the next one, we do the same thing. Rewrite it by bringing the -8 to the front, that dx up top. Instead of 81, we just make that 9 squared. Instead of 9x squared, we make that 3x squared. Okay, so we know our a is equal to 9. Our u is equal to 3x. Okay, differentiate both sides. Du equals 3 dx. And that just gives us dx equals du over 3. All right, so now we just plug that right on in. Okay, so we have our -8. Our dx is 1/3 du. Over the square root of 9 squared, which is our a squared, minus 3x squared, which is our u squared. So we get that 1/3 and just bring it down to the front. It's -8/3 du over the square root of a squared minus u squared. So now we can just go ahead and plug it in. Sine inverse of u over a plus c. Don't need that. Plug in our u and our a. -1/3 sine inverse of 3x over 9 plus c. Simplifying that just gives us sine inverse of x over 3 plus c. All right. So any questions on that one? Yes.
Are these really the simple?
Yeah.
They're-
I know you get scared when they're that
Yeah.
simple. Yeah, these are actually that simple.
When does this get tricky?
Yeah, yeah. What is the
Where's it
exception?
coming?
It kind of gets tricky
Because like I'm on the
for
over
the.
right now, and I got so it actually is it's a definite integral, but it's -5 divided by x square root of 100 x squared minus 100.
Yep, we're actually going to go on those next.
Next, okay.
Yep, that's when we
Okay.
get to the tangents and the secants.
Okay. Okay.
Yeah, but they're pretty much the same way. If you
Yeah.
know the formula, it's just identifying them, plugging them in, pretty much the same thing. So you can actually exhale because it's not gonna, the shoe's not gonna drop.
Okay. Cool.
All right. Move this over here. Okay, so now we're going to use the tangent. Over a squared plus u squared equals 1 over a. Tangent inverse of u over a plus c. Okay, so we're going to do a few with the tangent, then a few with the secants. And you'll see it's pretty much just the same thing over and over, just memorizing certain formulas. Okay, so let's say, for example, excuse me, if we wanted to evaluate the integral of 1 over 9 plus 4x squared with respect to x. All right, so just like before, first thing you want to do is rewrite it. You don't have an exponent, you have to, numerator you have to bring over, so you just get your dx and put it up top. Instead of 9, you can make that 3 squared. Instead of 4x squared, just make that 2x squared. Okay, so we know our a is equal to 3. We know our u is equal to 2x. Okay. Since you know our u is equal to 2x, that means that du is equal to 2 dx, which means our dx is equal to du divided by 2. Okay. So now we just start substituting. Okay. So we have the integral. Remember our dx, that's 1/2 du. And I always write it as a fraction times du, so I can just factor it right on out. 3 squared, that's your a squared. Plus 2x squared, that's your u squared. So if we get that 1/2 and bring it right out to the front, that's 1/2 times the integral of du over a squared plus u squared. Okay, so now we just solve it. So that's 1/2 times 1 over a. Now for tangent and secant, don't forget that 1 over a. Can't tell you how many points I lost as a student for getting that 1 over a. So 1 over a times the tangent inverse of u over a plus c. Actually, you don't even need the... I guess I'll leave it there just to kind of separate it a little bit. Okay, so we have our 1/2 that we still have to bring down. Our 1 over a, remember our a is equal to 3. So that's 1/3. Tangent inverse of u over a, that's 2x over 3. plus c. So all we have to do here is just multiply our 1/2 and our 1/3. Oh, there we go. Okay, 1/2 and 1/3 is 1/6. Tangent inverse of 2x over 3. And 1/2 times a constant is still a constant, so it's just plus c. And you're all set. All right. Any questions on this one? All right. Sure everyone's... All right, start with the next one. Okay, so let's say, for example, we wanted to evaluate the integral of 3 over 4 plus 100 x squared with respect to x. Okay. Steps are exactly the same. Just rewrite it. At least that's usually my first step. So just bring that 3 down to the front, bring that dx up top. And instead of 4, just make that 2 squared. Instead of 100x squared, just make that 10x squared. Okay, so we know our a is equal to 2. And we know that our u is equal to 10x. Okay, so we differentiate that. We have du equals 10 dx, which means our dx is equal to du over 10. Okay, so now we just substitute. Okay, so we have our 3 out front. Remember, your dx is du over 10, or 1/10 du. We have our 2 squared, which is our a squared. We have our 10x squared, which is our u squared. So if we get our 1/10 and just bring that out to the front, that gives us 3/10 du over a squared plus u squared. And then we just substitute. So 3/10, and that would be 1 over a times the tangent inverse of u over a plus c. And we know our a is equal to 2, so that's 3 over 10 times 1/2 tangent inverse of u over a, so that's 10x over 2 plus c. So 3/10 times 1/2 is 3 over 20. Tangent inverse 10x divided by 2 is just, oh, sorry about that, 5x plus c, because 3/10 times a constant is still a constant, so that just stays c. And that's your answer. All right, any questions on this one? All right. All right, I'll let you get started on this one. So let's evaluate -7 over 64 plus 36t squared with respect to t. I'll put a second one up there. Alright, start on those two. Same one. You're just going to factor out the negative 7.
Right. So would that change it to a base numbers then?
Because once you bring the negative 7 out front, it would just be the same one. Because everything inside of there is 2.
So if I did factor that out, then
Oh no, if you wanted to, if you make that negative 7 times whatever that is, if you want to just make that positive, you could just make it 7 cosine of whatever. Yeah, that's the only difference between the sine and the cosine is, and then one's negative, one's positive.
so
So if you just made it a negative sine of whatever the answer is, then that would be still a good answer. Okay, so let's start on this first one. Okay, so the first thing I do there is rewrite it. So you can get that negative and 7 and just bring it right out to the front. Bless you. Get that dt and just bring it right up to the top. Instead of 64, you can just make it 8 squared. And instead of 36t squared, you can make that 6t squared. All right, so we know that our a is equal to 8. We know our u is equal to 6t. This means our du is equal to 6 dt. We divide both sides by by 6. Our dt is equal to du over 6. Okay. So now we just plug it in. Okay, don't forget your negative 7 out front. Our dt is du over 6. So you can make that 1/6 du. We have our 8 squared, which is our a squared, plus our 6t squared is our u squared. Okay, so if we get that 1 over 6 and just bring that out to the front, we have negative 7 over 6 times the integral of du over a squared plus u squared. Okay, which gives us negative 7 over 6 times 1 over a tangent inverse u over a plus c. Okay, so we know that a is equal to 8. So negative 7 over 6.
Move it up.
Oh, sorry. There you go. So we have 1 over 8. Tangent inverse u over a, so that's 6t over 8. Plus c. Negative 7 times 1, that's just negative 7. 6 and 8 is 48. Tangent inverse, that just reduces to 3t over 4 plus c. And that's your final answer. All right, any questions on this one? Okay. Now, if you wanted to, which you don't have to, this is more than good enough of a final answer. If you wanted to just make that positive, you can make that 7 over 48 cotangent.
Move it up.
Oh, sorry about that. Cotangent inverse of 3t over 4 plus c. Okay. So that's really the only difference between the two. Is one's positive, one's negative. So by this being negative, you could have used the cotangent definition. But you don't really have to, because this is more than sufficient of an answer. Okay. Any questions on this one? All right. Get the next one. Okay. So first thing you want to do is rewrite it. Just bring that negative 9 right out to the front. Bring that dx right up top. Instead of 16, just make that 4 squared. Instead of 4x squared, we can just make that 2x squared. Okay. So we know our u is equal to 4. No, not u is equal, a is equal to 4. Sorry about that. And our u is equal to 2x. Okay, which means our du is equal to 2 dx, which gives us a dx that equals du over 2. And now we just plug it in. So we have our negative 9, our dx, we know that's 1/2 du, over your 4 squared, plus your 2x squared, which is u squared. Again, just bring that right out to the front. That's negative 9 over 2. Integral of du over a squared plus u squared. And then from there we just substitute our negative 9 over 2 times 1 over a tangent inverse of u over a plus c. Okay, so we know our a is equal to 4, so that becomes negative 9 over 2 times 1/4 tangent inverse u over a is just 2x over 4 plus c. Multiply those two, we have negative 9 over 8 tangent inverse. 2x over 4 just becomes x over 2 plus c. And that's your answer. Yes.
Can you do an example with definite balance?
Oh, yeah.
With like for the tangent function, inverse tangent function of like negative 3 square root of 3 to positive 3 square root of 3?
So let's
Or like
say
too specific.
with this one, let's say if we made it from 0, I think 0 to pi should be okay for this one. Okay, so let's just kind of tweak this a little bit and say we wanted to find out the integral of negative 9 over 16 plus 4x squared from 0 to pi. Okay, so if we did all the factoring and everything, with respect to x, okay, so let's say we did all the factoring and we ended up with our negative 9 over 8 tangent inverse x over 2. Wouldn't really need the plus c. That's from 0 to pi. Okay, so we have our negative 9 over 8. Should be tangent inverse pi over 2 minus, scoot that up a little bit, tangent inverse of 0 over 2. Okay. Remember with tangent inverse, this is basically saying, I'm running out of room here, let me grab another sheet. The tangent inverse, so if you say y equals tangent inverse of pi over 2, then if we apply tangent to both sides, tangent of y is equal to pi over 2, then we just have to find the y value that makes it equal pi over 2. Okay. Same thing with 0. If y equals tangent inverse of 0, tangent of y equal to 0, we just have to find the y value, or the y, I guess you could say the y degree, or in this case radian, that actually makes tangent equal 0. Okay, so we know that tangent, I'll say y equals sine over cosine. Okay, so we know sine is 0 for 0, pi, 2 pi, 3 pi, 4 pi, etc., and so on. Did the problem give an interval? They say from 0 to pi, or? But, well, we already have ours from 0 to pi, so.
It was from negative square root of 3 over 3 to positive 3 square root of 3 over 3.
Oh, okay. Well, you can still use it the same way. All right, so if we have our pi over 2, tangent y equals pi over 2, so that would be sine of 0, so that would be actually 0 or pi for this one. And for pi over 2, that would be sine of 0